Experiment number 13, verification of the relationship between the frequency of a stretched string and its vibrating length using the sonometer. For this practical, we need a sonometer, set of weights, a 2 kilogram weight, and a light paper rider. Right. So here, this is the second experiment of sonometer that we have in our syllabus. For this experiment, we are going to use set of tuning forks, not just one tuning fork, a set of tuning forks. So as you remember, in the previous experiment, we used one tuning fork and we found the frequency of that tuning fork. And here we are using a set of tuning forks. So these tuning fork sets have tuning forks of different heights. As you can see in this diagram, in a set of tuning forks, you have tuning forks like this. On the tuning forks itself, the frequencies are stated, as well as you can make them in order by looking at their heights. So the shortest tuning forks are the ones which have the highest frequency, and the longer tuning forks are the ones which have the smallest frequencies. So that I have given you as a point. So here, the method of doing the experiment is that by changing the frequency, and with the frequency what changes is the resonance length. Here also you can see it's the same equation that we have used in the experiment before. So here the variables is f and l. So you rearrange the equation in a way that you get y equals mx type of a graph. So here, in order to get a straight line y equals mx type of a graph, we take L for the y-axis and not f for the x-axis, but 1 over f for the x-axis. So x-axis here is 1 over f and y-axis here is L. So from the gradient, we can't find anything, we are not going to find anything. We are going to verify. We are going to check whether that if we are getting a straight line which goes through the origin, and if so, the verification is done. So this is a verification experiment. So how you verify this is by getting a straight line which goes through the origin. Right. So in this experiment, we need to know with which frequency of the tuning fork that we are going to start. So according to the equation that we got, you can see when the frequency is high, the length is less. Higher the frequency, lesser the length. Lesser the frequency, higher the length. Right. So it is advisable to use the tuning fork with the lowest frequency first, so that you get the maximum resonance length. So in that way you can make sure that tuning fork with the lowest frequency is going to get a resonance length or not. If you do not get a balanced length, not a balanced length, the resonance length. If you do not get a resonance length for the tuning fork of the lowest frequency, it means you cannot utilize the set of tuning forks that you have. So we have an option for that as well. And that option that we have is that if we don't get a resonance length for the tuning fork of the lowest frequency, then we can use this equation. So you want to reduce the length here. So you are going to reduce the tension. So you can change this mass. You can reduce this mass that you hang in the wire, so that the resonance length will also reduce. So this is how we are going to do this experiment. So if you can make sure that you get a resonance length for the tuning fork of the lowest frequency, or the tuning fork with the largest length, that means you can get resonance lengths for all of the other tuning forks as well. So other than those points, everything else in this experiment is similar to the previous experiment you have done. So if you are getting an equation, a graph like y equals mx, then you can say it is verified. So that is how we do this practical.